All right, guys, nice to see you guys again. So let's take a little bit of inventory of what we've done so far with this chapter. This chapter is about techniques of circuit analysis, and we just covered one extremely important technique of circuit analysis called the node voltage method. Keep in mind that this was a generalized technique of circuit analysis in the sense that it can pretty much be applied to any circuit. There is one other very common and very important technique of circuit analysis that we want to begin discussing now. This new method is called the mesh current method, and we're going to begin the same way that we began our discussion with the node voltage method by firstly introducing some definitions that need to be laid down formally before we can actually start talking about the technique properly. So this section now is on the mesh current method. Now, this is another generalized technique of circuit analysis. Like the node voltage method. This is worth repeating. However, and this is important, so I'm putting this in red so you can really see, unlike the node voltage method, which could be used to analyze any circuit whatsoever, there's a restriction here. So you have to be wary of this. Now, keep in mind that the circuits themselves that we're going to be seeing in this class, and most of the circuits that you see in most of the other classes, you will be able to use the mesh current method in order to analyze them, but keep in mind that it doesn't apply to absolutely every circuit. And the restriction is the following. This method only works for a special kind of circuit called planar circuit. So this only works for planar circuits. Now let's move on to the definitions that we really need to lay down. The first definition is, well, if it only works for a planar circuit, then what in the world is a planar circuit, right? Let's be very clear with our terms. So planar circuit. A planar circuit is a circuit that can be drawn on a plane with no crossing branches. In other words, if you can draw it on a plane and you don't have any overlap between branches, it's a planar circuit. Now, sometimes it's tricky to tell whether something's a planar circuit or not. But one kind of circuit that might be a non-planar circuit is, imagine you had a set of resistors all along the edges of a three-dimensional cube. No matter how you squash that cube onto a plane, there will always be branches that overlap. You cannot rearrange the branches in such a way that they lie on a plane without branches crossing. Now again, these types of circuits in practice tend to be relatively rare, right? There are some nice illustrations in the textbook also that show you when circuits are planar and when they're not. So I really recommend that you take a look at the textbook because they have some really nice examples there. The next definition is something that we've seen before, and it's the definition of a mesh. If you will recall, a mesh was a loop that did not enclose any other loops. So that's worth writing down. It's a loop that does not enclose any other loops. In this sense, they can kind of be thought of as kind of like the building blocks of circuits in some senses. Right. The last definition that we need to lay down before we can really start talking about the mesh current method properly. Just like we needed to define node voltages as opposed to terminal voltages, I want to define mesh currents as opposed to the currents that you've been dealing with up until date. These are called branch currents. And there is a distinction between the two from time to time. So the mesh current definition is as follows, is a current that exists only in the perimeter of a mesh. And we'll see how these definitions will help us develop this new technique of circuit analysis in the next few videos.